In this example you can see a disc with 6 equal cutouts which are being rotated over 60 degrees. So in this case we would only need to define one of these cutouts, and at the end we can copy rotate them. So we select our cutout on the right side, right here, and we will move on to NC jobs and machine area. So we'll start answering the questions of the dialog box, and we'll click on OK. Would you like to load a new tool? Yes, we would like to load a new tool. And for example, we can load a tool of 10 mil, for example, diameter, and well, we don't have one of 10, so we'll select a tool of flat end 8. Okay, select. Okay. The reference point is G54, and here we can enter the parameters of the job. So we'll start at Z0. The depth might be 4 mil, and we can enter a step depth also of 4, and we'll leave no allowance on it, and we'll enter an overlap of the tool of 60%. Okay. In this case we can choose the strategy Z level, which in this case wouldn't make any difference because this shape will give you the same result. So we'll click on OK, and the start height and retract height is 10, and you can see the tool path for this cutout. So we'll convert this into NC code, and we will answer the question, would you like copies with yes? And now we can choose what kind of copies we would like, either translate them in XY or rotate them. Well, in this case we'll select the rotate. OK, and our rotation point in this case is X0, Y0, so we'll leave it to this. We would like 5 copies, and each copy is 60 degrees. OK, so here we get 6 copies, and you can see in the NC program here our tool is loaded, and there's our first cutout, and you can see there are 6 cutouts generated. So if we would simulate this, we'll click on the eye, we'll move to the tensor simulator and click on the eye, and here's our disk, and start simulating, and so you can see our NC program simulated. So it's quite easy in Tensor. If you have a symmetrical part, you can either use the rotation or you can translate your toolpath, so you don't need to define all different parts separately. So in the bottom you will see the machining time using these feeds, and you can rotate your part a little bit so you can see how it looks like in 3D. Well, let's move on to the next example of Tensor.